Now let's look at the last one, which is so we've dealt with this, we've dealt with this, we've dealt with all of this. Now we're left with sensitivity analysis. Now let's look at sensitivity analysis. Sensitivity analysis. What is sensitivity analysis? It's just a way of asking ourselves, after we have calculated NPV, there are two outcomes that we can get. Either we have a negative NPV or positive NPV. I know we can have zero as well, but not likely, because zero does not tell us anything. But in terms of taking decision, we cannot take decision based on NPV of zero, or we can rather say even ignore, because it's not adding any value to us. So, which is still similar to the decision we would take under negative NPV, ignore. So our decisions will rather be don't do the investment, do not, or do it. So there are only two major decisions that we can take based on our NPV outcome. Is that we don't want to do it or we want to do it. Now, sensitive analysis is important because it helps us to check, considering all the variables we have used. We have used cash flows, and in that cash flows, there are different types of components we have used. There's sales, which is also revenue, which is a function of price and volume. We have used costs, which can also be variable cost or fixed cost, step cost. We've used discount rates to discount our cash flows to PV and to get NPV. So these are different things. Likewise, we invested money, so there's initial investment, which is part of our cash flow as well. Right. So these are all components of our NPV that we have calculated. So when we are doing sensitivity analysis, what we are saying is, how much can any of these items change for us to change our decision from here to here, or if we are here, from here to here? Is it just 1% change can make us change our mind, or we need almost 80% or 100% change for us to change our mind? So this is very important because it helps us to know how solidified, how robust the NPV is for us to take a decision. Because if just 0.1% change in one variable will make us change our mind, then that means we don't want to take that kind of investment decision, because we already know that the future will never be the actual. Of our plan. The future actual will never be the same as what we have planned. So we need a plan, we need a forecast that gives us huge room of sensitivity, that gives us huge room of what we call the margin of safety, such that we know that when we take that decision, before that decision can change from do it and do not do it, or do not do it to do it, there has to be huge change, which is very unlikely. And that is what sensitivity is talking about. So it's about looking at one parameter at a time and see how that can change our mind, how that can change our decision. And that is what we need to do in this part of risk management. So what we'll be using is what we call the margin of safety, and that is calculated as NPV of the project divided by, so margin of safety, MOS, is equals to NPV of the project divided by the PV of the cash flow that we are looking at under consideration, right? So the cash flow of the variable or the parameter under consideration. So if we are checking, take for instance the margin of safety on initial outlay, it will be NPV of project divided by the present value of the cash flow of initial outlay, which is the initial outlay amount. So let's look at a question quickly, and we can use that to quickly learn this margin of safety and interpretation, likewise a calculation. So I will go to a question that I think will be useful for us. So let's look at this question. Yeah. So let's look at this. So we have, for this investment, we have the initial outlay of 50,000. Then every year we have 22,000. Then we have additional information on that, how that 22,000 was gotten, which is volume of 10,000 per year. The fixed cost is 8,000. Selling price is 10 per unit. Variable cost is 7. You can see if you have selling price of 10 minus 7 variable cost minus fixed cost that is relevant, you see that your profit per year is actually fixed cost is, we can't do that for fixed cost because it has to come in after we've gotten our contribution, remember. So contribution is 3. So, and that is total contribution of 3 times 10,000 units, and that's 30,000. Fixed cost of 8,000, then the profit is 22,000, which is the annual cash flow you can see for each year. Now, if we need to get the sensitivity for each of these items that we've identified here, components of our NPV. Yeah, so let's start with the initial outlay. So before we do that, we need to get the NPV. Remember, the margin of safety is NPV of the project divided by PV of the cash flow under consideration. So let's do the NPV quickly because we need that for all the margin of safety we'll be calculating. So we'll plot our cash flow. Year 0 is 22,000 every year, so I'm going to use annuity factor to make it quick. Right, so here the cash flow, we'll plot it. We're going to use 50K. Yeah, in year 0 we invest 50K, but every year we'll make 22,000, and we have a discount factor. What cost of capital should we use? Let's use 10% to make it quick. So let's say cost of capital is 10%. Then year 0 discount factor remains 1, and annuity factor for 10% for 3 years is 2.487, and that gives PV of minus 50, and 22 times 2.487 gives 54.7, and that gives a positive NPV of 4.7. Yeah, so that's about 4,700. Yeah, so remember we worked in thousands just to make it quick. Right, now we have the NPV. Now we need to do the sensitivity, so which means we need to calculate margin of safety. Right, so, and let's start with initial outlay. Yeah, because I want to do each of them for you, because sometimes you need to know the parameters to use. Sometimes it's not as straightforward as this formula, so I'm going to show you everything here. For initial outlay, it's very straightforward. Initial outlay, the cash flow is what? Is 50K. So which means our margin of safety for this one will just equals to 4.7 divided by 50 times 100, and that will equals to, do that, 4.7 divided by 50 multiplied by 100, and that's 9.4%. So the margin of safety for initial outlay is 9.4%. And what does this mean? It means that the NPV of the project equals 9.43 of the PV of the capital invested. And what does it mean in terms of interpretation? We are saying that if the capital investment, this initial outlay, if it dare increases by up to 9.4%, then our NPV will not be positive again. That is what it's saying. Remember, the higher the cost, lower the NPV. So if we are talking of revenue now, it will be opposite. So follow and listen carefully, because this is a cost. Initial outlay is a cost, yeah, which means it's an outflow. So the higher this, the lower the NPV. So what margin of safety of 9.4% is saying is that if the initial investment, which is our initial outlay, increases by 9.4% or more, the NPV becomes negative, and therefore the investment will not be undertaken. Because even in your MCQ question, you can be given this margin of safety and pick the right answer that interprets the MOS, margin of safety, properly, right? So that's how to interpret it. So that's for initial outlay. We can also do for price, selling price. For selling price, if you have to do for selling price, you need to work with PV of cash flow of the revenue, because that's the price. Remember, the PV of initial outlay is 50,000. It's the easiest one because this investment is done today. So the PV is today. That's still the value. It does not change. So it remains as it is like that, right? So you don't need to use any factor for the initial outlay. However, for the other ones, then start looking different. So for price, you can't divide just by price, because the PV you got, the NPV you got up there, this NPV, is for everything, all the volumes, all the things. So you cannot just use PV of price. You have to use PV of revenue. So which means sensitivity for price will be equals to same NPV, which is 4.7, and price, we said we're going to use revenue. So revenue that happens, 22,000 is profit. So but revenue is volume times price, which is 10 times 10. That's 100,000. But remember, this 100,000 happens every year for 3 years. So the PV will be times the annuity factor. So annuity factor for 3 years at 10% remains 2.487. And that makes, and times 100 to get our margin of safety. So that equals to 4.7 divided by 100,000 times 2.487 times 100. And that gives 1.9%. Remember, this stays in bracket, so that gives 1.9%. If you want to press this and calculate, the best thing is you do the denominator first, like 100,000 in case of, depends on the calculator you are using, but to be safe, multiply 100,000 by 2.47, so you have 248,700. Then you can now say 4.7 divided by that answer. Then you can now multiply by 100 to get your percentage right. Remember, this is gross figure, 100,000. This is in thousand. So if I want to put it properly for you, I'll go 4.7, so that it's absolute figure wise. Remember, the 4.7 we got here is in thousands, right? So don't get it confused. Or if you want to stick to 4.7, I can just leave this out. So it's still going to give us the same answer. I say 4.7 because we are working in thousand, and 100 times 2.487 times 100. This will all still give you the same thing. 4.7 divided by 248.7, and multiply by 100, and you still have a 1.9%. So please take note, it's the same thing. This one and this one is all the same, just that this one is absolute while this one is in thousands. Okay, so that's sensitivity for price. How do you interpret this? What you're saying now is that because this is revenue, this is about price, this is about inflow, so it's opposite of cost. So what you are saying is that if the price reduces by 1.9% or more, what happens? NPV becomes negative, and therefore, no, you will not do the investment if it reduces by 1.9%. Okay, that's sensitivity about price. The third one, let's do it on volume. So on volume, because volume affects both revenue and affects variable cost as well. Remember, your total variable cost is variable cost per unit times volume. Likewise, your total revenue is price times volume. In that case, you can't use either of them, but you need to use something that combines both of them, and that thing is called contribution. So for volume, the cash flow we'll be using is contribution. And that's, if you remember, we calculate contribution earlier, and I think we got 30,000 for our contribution. Yeah, got total contribution of 30,000. So for volume, we'll be using contribution of 30,000 per annum. So which will do the margin of safety to be equals to 4.7 over 30,000. We're working in thousands, so 30 times 2.487, which is our annuity factor, and that gives 6.3%. Yeah, so that is volume. And contribution, because contribution is a positive thing, so which means that if volume drops or reduces by 6.3% or more, NPV turns negative and investment becomes not acceptable. That's sensitivity on volume. Let's move on to the sensitivity on fixed costs. Fixed cost is just fixed cost, and that is given to be 8,000 per year, so very straightforward. So which means the margin of safety for the fixed cost is 4.7 over 8 times same annuity factor. That's how to get our present value, and that gives us 4.7 divided by 8 times 2.487, 23.69. So this looks really good, this particular one, because it's high. The margin of safety is high. We are saying that the fixed cost must increase by at least, I'm still saying the same thing, 23.6% for NPV to be negative, and therefore making it not acceptable. The last one is there is sensitivity on discount rate. Please pay attention. This is probably the most difficult part. This one, you don't use the margin of safety formula. What you need to do for sensitivity of discount rate is to calculate what we always know, and that is IRR. Because when you know the rate where the NPV becomes zero, you know that anything higher than that rate makes your NPV to be negative, because the higher the rate you have, the lower the NPV that you will get, right? So which means that for this investment, we need to calculate IRR. So we need two NPVs. We already have one NPV at 10%, so we can do another NPV at 20%. So let's do NPV at 20%. So year 0, year 1 to 3, cash flow minus 50 in 22. We have discount factor at 20%. And we have the PV. And we can get our NPV at 20%. So let's get the discount factor quickly. So the discount factor here is 1. Annuity, 3 years, 20%. That's 2.106. So this is 2.106. So this is minus 50 and the other one 2.106 times 22 as 46.3. So our NPV becomes negative 3.7. So, and we know that IRR, so let's go quickly on this one. So IRR, our formula is L into bracket plus NL into NL minus NH into bracket H minus L. So we know that L is 10% plus NL of 4.7 will go to bracket 4.7 minus 3.7 into 20% minus 10%. So that equals to 10% plus, I'll do this one first. So that's 4.7 divided by 4.7 plus 3.7. So 4.7 plus 3.7 is 8.4. So 4.7 divided by 8.4, that equals to 0.56 into bracket 10%. So that equals to 10% plus 5.6%. And that equals to 15.6%. So that is IRR. And at this point, we know that at IRR, NPV equals to 0. So which means what we are saying is that discount rates, that's your sensitivity. So your discount rate must be higher than 15.6% for NPV to be equals to negative, rather, because at 15.6 it is 0. So anything higher than 50.6 it becomes negative, and that is why at that point it becomes unacceptable. So the cost of capital of this company is 10%, but we're saying for us to change our decision to do the investment, that NPV, that rate, the cost of capital must be higher than 15.6. So that's almost like 50% increase, more than 50% increase in discount rate for us to change our mind. And that is everything you need to know about risk and uncertainty. That will be it for that risk management. In the next video, I'll do a question on the last part of scenarios or concepts you need to know on investment appraisal, which is lease or buy. But until then, thank you. Remember, like the video and share. Bye.